Hey there, pre-calculus students. I wanted to go over partial fractions with you and partial fraction decomposition to give you an idea of how to do your homework a little bit. So let's look at question number 23, where it says x squared plus 12x plus 12 over x cubed minus 4x. What we are looking for is a way to break this. So this is a division right here, a fraction. But we're looking for a way to write it as a sum of fractions. All right. And so the first thing we want to do is factor this completely, the denominator. So the first thing I would do is factor out an x. So I'd have x times x squared minus 4 plus, and then this x squared minus 4 can be factored further, right? That's a difference of squares, so that becomes x plus 2 times x minus 2. And so these are each linear factors, and so each one of these would become the denominator of one of our fractions, right? And so this is the form of decomposition. Now, this equation is equal to this equation, right? And so I've rewritten that, but we are going to multiply both sides of the equation by this guy's denominator. Now, on the left side, I'm just using it as x cubed minus 4x so that they cancel. On the right side, I'm writing it as the factored form, right? X times x plus 2 times x minus 2. Now, I'm multiplying every term on this right side by those three things, right? X times x plus 2 times x minus 2. Here, the x's would cancel, and you would have a times x plus 2 times x minus 2. Over here, the x plus 2 cancels, and you are left with b times x minus 2. And with c, the x minus 2's cancel. So you're left with c times x plus 2. And I wrote the numerator down here, right? We bring that down. So I simplified, and then I distributed the a through. So I have ax squared minus 4a, and I have bx squared minus 2x times b, plus cx squared plus 2x times c. Now they want you to write three equations, right? We need to solve for a, b, and c. And so my x squared terms, I gather my x squared terms together. X squared is just 1x squared. Then I have an ax squared plus a bx squared plus a cx squared. Those terms all have to add to 1, right? So 1 is equal to a plus b plus c, because those are just the x squared terms. Then we've got the x terms, right? So we'll do 12x is equal to, there's a negative 2xb and a plus 2xc. And because those are all divisible by x, we can just make that 12 equals negative 2b plus 2c. And then constant terms, things without an x, there's a 12 and a negative 4a, and they have to be equal to each other. So 12 equals negative 4a. So I'm going to write these three equations as a system of equations, right? So a plus b plus c equals 1, negative 2b plus c, 2c equals 12, and negative 4a equals 12. I want to solve this system of equations for a, b, and c. So the first thing I'm going to do is take that third equation and divide both sides by negative 4, and I get a equals negative 3. And then I'm going to substitute that into this top equation and write it over here. I have negative 3 plus b plus c equals 1. I'm going to add 3 to both sides, so I get b plus c equals 4. And I copied down that second equation right below it, negative 2b plus 2c equals 12. So now I have two equations and two unknowns, and I can solve this system. I'm going to take that top equation and multiply it by 2, right? So I have 2b plus 2c equals 8, and then I have negative 2b plus 2c equals 12. When I add these two equations up, the b's cancel, right? And 2c plus 2c is 4c, and 8 plus 12 is 20. So I have 4c equals 20, and then I will divide both sides by 4, and I get c equals 5. So if c equals 5 and a equals negative 3, I can solve for b. B equals 5 plus b plus 5 equals 4. Subtract 5 from both sides, b equals negative 1. Now, my goal is to find a, b, and c, but then I need to write them in the fraction form. So it needs to be negative 3 over x minus 1 over x plus 2 plus 5 over x minus 2. Okay, that is a lot of work there, but I hope that it helps to explain this partial fraction stuff a little bit. If you have questions, always ask. We'll see you next time.